Many different deep foundation and retaining wall solutions are available to engineers. Among the most accepted options is steel sheet piling, which by definition is a structural steel section with interlocks on the flange tips, enabling the joining of sections to form a continuous wall that is earth-tight. Sheet piling can be used in temporary or permanent applications for marine, environmental, and transportation projects, and is most commonly available in two shapes: flat sheet and Z-profile. While flat sheet piling is used for interlock strength in circular structures, Z-profile sections are used for their beam strength. In essence, they are like a wide flange beam, in that each section has flanges and a web, the geometry of which gives it strength. These sections are typically used in bridge abutments, retaining walls, bulkheads, cut-off walls, cofferdams, foundations, and levee construction. Two production types of Z-profile steel sheet piling are widely available: hot-rolled and cold-formed. The important distinctions between the two can mean the difference between a successful project and one prone to problems. The names of each production type are generally descriptive. Hot-rolled piling is manufactured in much the same way as wide flange beams, with a billet heated to approximately 2200 degrees Fahrenheit passed through a series of roll shapes until it achieves the required geometry. Cold-formed piling sections begin as cold steel coil, which is decoiled and sent through multiple rolling stands without preheating. In this relatively new process, the sections, including interlocks, are literally bent into shape. The difference in manufacturing process creates a tangible disparity in the interlock strength, corrosion resistance, and structural integrity of the finished structure. While both cold-formed and hot-rolled piling sections feature interlocking connections, the preferred ball and socket interlock is only available with hot-rolled piling. Additionally, the bent interlocks of cold-formed piling are not engineered to withstand the rigors of difficult driving conditions and do not provide tensioned interlocking to prevent water seepage. To design a structure with sheet piling, engineers commonly look first to section modulus and yield strength as the primary criteria, but these considerations alone provide an incomplete picture of structural integrity requirements. Studies conducted by Dr. Richard Hartman at the State University of New York, Buffalo, showed cold-formed piling consistently failing at 83% of its theoretical strength. Conversely, like-sized hot-rolled piling was shown to maintain structural integrity up to 142% of theoretical strength. The results of these tests, which have never been disproven, form the basis of the Hartman factor, in which a factor of 0.83 should be applied to the strength properties of cold-formed sheet piling. While engineering calculations may account for the theoretical bending moment of a sheet piling structure, Dr. Hartman's study demonstrated additional transverse stresses on the wall, exposing the inherent weaknesses of cold-formed piling at the bends or corners of the piling sections. The production process of hot-rolled piling allows for a design with the appropriate amount of greater thickness at the corner of the flange and web, providing greater structural integrity than is possible with cold-formed sections. The corner bends and the severe cold working of steel at the interlocks of cold-formed piling present another significant concern for the specifying engineer: corrosion. Cold working and overstrain accelerate localized corrosion known as pitting. Cold-formed sheet piling is therefore more susceptible to corrosion at the bends. Since this is where the stresses are concentrated, the early onset of corrosion will mean an inability of cold-formed sheet piling to achieve their design life. In contrast, the extra steel at the corner of the web and flanges of hot-rolled sections provide the capacity to manage the localized stresses. Testing standards are a critical component of choosing appropriate materials, and ASTM International is the recognized leader in establishing and maintaining standards for manufactured products. ASTM Standard A6 deals specifically with rolled structural steel sheet piling, establishing testing requirements that engineers and construction professionals should insist on receiving, including grade of steel, heat number, that is a designation of exactly when and where the raw steel was created, heat analysis, detailing the specific steel chemistry of the heat, and nominal section size. Also included in ASTM Standard A6 is the requirement for 2 tension tests per heat. While this is a standard practice for hot-rolled sections, it is uncommon for cold-form sheet piling suppliers to have this information available. From the manufacturing process to interlock strength and even the ability to meet ASTM testing standards, cold-form sheet piling simply doesn't measure up to the structural integrity and corrosion resistance of hot-rolled sheet piling. These are among the reasons that the U.S. Army Corps of Engineers, in the Unified Facilities Guide Specifications 31-41-16, called for hot-rolled piling to be used in applications in which section stability or interlock joint strength is a primary design requirement. In both permanent and temporary applications, such as transportation, deep water, and structural construction projects, hot-rolled sheet piling remains the most reliable and safe engineered solution. From the bays of Alaska to the levees of New Orleans, Gerdau sheet piling has demonstrated its effectiveness as the North American leader in hot-rolled piling. Rolling both flat sheet, PS, and Z-profile, PZC, Gerdau provides shapes to solve even the most stringent geotechnical challenges. PZC, the wider, lighter, and stronger configuration of Z-profile piling, features a ball and socket interlock that allows for easier and more flexible setting and durability through driving. As a global leader in long steel production, Gerdau is driven to deliver the most reliable and strongest piling products in the world, providing you with secure solutions that perform beyond expectation. Learn more about Gerdau sheet piling and solutions for projects at sheet-piling.com.